Hi, and welcome to this session. So, as we promised before, from this session on, we will talk about the graphical user interfaces. And I wanted to mention this before everything, and that's that from this session, we will try to actually, I've hosted this project in the GitHub, and I will try to push, have a commit at the end of each session and push the result to the commit to this repository in the GitHub. Now, and that's one thing that I wanted to mention. So yeah, you can access the source code of this project from this session at this repository in the GitHub, which is a public project. Okay. So as we said before, so far we just have this this textual user interface for as a way for interacting with this application, and we want to change that. We want to move toward graphical user interfaces, and we can actually, we've got a bunch of options, a lot of options actually. For example, let's take a look at this Flutter. Flutter is a new framework which has been there actually I think from 2018, and it's very stable now. It's the Flutter version 2 is out now. It's been a month, I think, and you can actually publish an application to all the platforms that you know, for a web application, mobile application, Android, iOS, Windows, Mac OS, and Linux application. Just without even changing a single line of code. Just so the Flutter is a new framework, and so we've got other frameworks like the Android native framework itself, which is also provided by the Google. The Flutter itself is provided by the Google, and the Android is the Android native framework, and it's just for writing applications for Android devices, just that. But the Flutter, which writing Flutter applications, you can export your application to web and other platforms desktop just with a click of a button. Also, we have this, for example, the React Native, which is like the Flutter, and you create native iOS and Android applications, not native like Flutter, but native like, the performance is acceptable. And but the Flutter not only is capable of releasing Android and iOS, you can have web and desktop applications as well with the Flutter. Or for example, this Angular, which is also developed by the Google team and is for writing single page applications, web applications, just for web applications. I think it has some other capabilities for cross-platform capabilities. Maybe you can release for Android, or I'm not expert at this framework, but I just wanted to show you a bunch of options that when you want to be a front-end developer in some company, you have to be at least, you have to be fluent with at least one of these frameworks. For example, you are known as Flutter developer or Android developer. Yeah, we have these options, and there are few other options like JavaFX, which is mainly for writing desktop applications. For example, this IntelliJ IDEA that we are using here for developing applications and writing programs is a desktop application itself. It has this UI here that we are clicking and typing, and it doesn't have a textual interface. It's a graphical user interface, and it's mainly developed in a Java Swing framework, and I think a little bit of JavaFX. And JavaFX itself has the cross-platform capabilities. You can export for mobile and I think for web. I don't know. I'm not sure about that. So these are a few prominent options that we can select from, and so at this point, you guys are probably saying that, for example, let's choose Flutter, or let's choose Android, or other things, other frameworks. But before actually diving into one of these prominent frameworks, first we want to, as we've promised, we want to talk about the internals of these frameworks and how these frameworks are working internally. And for example, take a look at here. This is the Flutter website, which is showing that you can describe your content, you can describe your user interface with just a bunch of, for example, classes. You're telling, okay, I want a text, I want other text in a column, and boom, yeah, you have it. And you just run it and you have your application. And for example, you describe that I want a floating action button down here, and just Flutter framework just does everything on your behalf and draws that button there and those texts and that action app bar at the top. And this is what most of the people need. Actually, they say, I don't care about the internals. I just want to be able to talk, for example, Android, or talk Flutter. I want to describe my UI to the Flutter, and I don't care how the Flutter is doing this magic internally. And that's fair, actually, because in your day-to-day job as a front-end application, you don't have to know anything about the internals. But here we want to compare these frameworks to each other, and we need to be aware of a little bit of the internals of these applications and how these frameworks. Sorry. And at the end of the day, of course, we will use and select one of these frameworks and use them, because we cannot write our own framework from scratch, like for example Flutter, because Flutter team in the Google, maybe there are 50, 100 guys maybe or more, and they are supporting, they are building tool chains, they are doing everything, these features that we cannot do these on ourselves, by ourselves. We have to select one of these or a bunch of these and use them as our day-to-day job. But we can try to have a miniature glimpse of, have a miniature framework and write a miniature framework ourselves and have a glimpse on the internals and the building blocks of these graphical user interfaces. So yeah, and so now that we want to write our own graphical user interface framework, so the question is that what is a graphical user interface? So let's take a look at this one here, which is an example inside the Flutter website that you are seeing. So here they have described the UI that is, the UI consists of a column, two texts, which is one here and the other one is here, and yet one button at the bottom and one action bar at the top. So actually we will see in a few episodes that graphical user interfaces like these, or like this one, or like the browser itself, all the graphical user interfaces, no matter the platform, no matter, for example, whether it's a web application, a desktop application, or mobile application, all of them, and also the games that you are playing, the fully fledged games that you are playing with modern graphics, and all of them are just a painting, a drawing on a canvas, actually. So even the movies actually are pictures, are frames that are being rendered, consecutively in very fast, that your mind tricks into that, okay, we have some motion here. And so the graphical user interfaces, as I said, are nothing more than a painting, a drawing on a canvas. And so what we need here is asking for a canvas, for an empty canvas from your operating system, just to be able to paint on and draw on that. And if you be able to get a canvas from your operating system, then we can write our own UI framework like the Flutter or Android. So I want to talk about here, now that we know we only need a canvas, I want to talk about this, that how this, from where we can access a canvas. So I don't know if you've heard about the OpenGL, Open Graphic Library. I think it stands for Open Graphic Library, if I'm wrong or right, I don't know. Yes, Open Graphic Library. So long time ago, actually, before we can read the history here, before 1991, actually drawing pictures and stuff on the screen is the responsibility of your graphic card, your GPU. So we command the GPU to draw stuff on a window. For example, we ask the operating system for a window. So for example, this is a window here that we can move around, and also the browser itself is a window, and it has own canvas. So here it has a canvas that we can draw, and you see a lot of drawings, you see these texts and these graphics and all that stuff. So in order to be able to draw something, to get a window, we have to ask the operating system. For example, here the Ubuntu that I'm using, or maybe you are using macOS or Windows, or even the Android. Nowadays the Android is more than a platform, it's operating system for itself. We can ask the Android for a canvas, for an empty canvas. So we want to talk about this, that not very long time ago, we had to actually talk to each GPU, each GPU, for example, AMD GPUs or NVIDIA GPUs or other companies have their own APIs. They release their own APIs as a language, for us to talk to their GPUs and command the GPU to draw stuff. In 1992, a group actually tried to develop a common language between the all GPUs, so that no matter the type of the GPU and the brand and the company, so that we can speak to the GPU, through a universal language, a common language. And they named this language OpenGL. So the OpenGL is basically a library, an API that makes it possible for us to talk directly to the GPU and command the GPU. And there are a few other options, like DirectX, I think you've heard about, which is for Windows. And they have this, for example, inside the DirectX, they have Direct 3D, which is for real-time 3D rendering. And actually, if you go, for example, to the website of your GPU, you can see that your graphic card now supports, for example, OpenGL and DirectX directly. So we can speak to your graphical card directly with the OpenGL language or DirectX library API language, whatever you call it. Or lately they have developed other API named Vulkan, which is more modern for multiple, which uses multiple CPU cores. Or for example, the Metal library or API is developed by the Apple, and they are using this in their iOS, in their devices like iPad and other stuff. And all these Metal, Vulkan, DirectX, and OpenGL, all of these are just a way to talk directly and command directly your GPU. So all of them, I think, are written in C languages. This one here says that it's been written in C, but we are using Kotlin, and we cannot use the direct implementation of these OpenGL C libraries. But fortunately, there are a bunch of libraries out there written in Java which are on top of the OpenGL and translate the Java commands to the C library. And one of them is this lightweight Java game library, LWJGL, which is mainly developed for, you can see here that it's saying that it's a Java library that enables cross-platform access to popular native APIs like OpenGL and Vulkan. So this LWJGL is a library that enables direct access to those libraries. And maybe here you say that, okay, we had promised that we will not use any frameworks or libraries, but I promise you that we cannot go actually more low level than this when we are going to talk to the graphical card, to the GPU. This is the last, it's like writing assembly code for your CPU. You are talking directly to your graphical card, So we are not using here any framework. Even we won't be using any other libraries written in the lightweight Java game library. We just want to be able to speak OpenGL, just talk OpenGL, and command the GPU directly. Just we will use this for that. And yeah, without further ado, let's just see how we can write a basic application. So we can use this library for writing games and applications, graphical user interfaces. And from the point of the view of these frameworks and libraries, there are no differences between a game and a graphical user interface. All of them are just the painting and the drawing on a canvas. Okay, let's see how we can add this to our project. We have the download section here at the top. We want to add the libraries to the Gradle. Here it says Gradle, and we want to run it in the Linux. The OpenGL is a cross-platform, operating system, cross everything, So if you be able to write applications with OpenGL, you can run it anywhere in Ubuntu, Mac, even in your devices. Okay, in the last version, and let's copy and paste these to the Gradle file, because we have to download the natives, the jar files and all those native files of this library. And also let's add these two here, and I think we are all set. Let's sync the project and download all those files. Okay, meanwhile, let's just take a look at this get started part here. In the get started part, they have written the simple Java code here, which will open a simple window. Will ask your operating system to open a simple window, and it will, I think it will draw a red rectangle. It will paint it with red color, and we are going to copy and paste it. We are not going to write Java applications, but if we copy and paste this, a Java code, let's copy, and let's because we want to write applications in Kotlin mostly, and let's have a Kotlin file here named test JWGL. I think I get it wrong. LWJGL, yes, sorry. LWJGL. And if I paste a Java code inside a Kotlin file, you'll see that we have this prompt that it wants to convert it to a Kotlin program. So if I click yes, it will try its best to convert it to a Kotlin program, all those Java codes that we copied, and it's done. And let's see if we can run it. And hopefully we will have a window. And yes, there you have. this is the window that you see. So by this framework, by this actually library here, we have asked the operating system for a canvas inside a window, because you have to actually have canvas, have a window. This is a window. It has these buttons at the top, and you have the canvas inside it. So now we are able to draw our stuff on this canvas, and let's see how we can do that. And we don't want to deep dive to the OpenGL library, because it's a lot. It's very not complicated, but it has a lot of moving parts in the OpenGL, and we don't want to get expert in the OpenGL itself. We just want to actually use its basic drawing stuff and have a canvas just to write our graphical user interface, just that. So let's search here and see how we can, for example, OpenGL, for example, draw line, how we can draw a simple line. Let's see. And as you can see, I'm just searching for OpenGL. I'm not searching for Java OpenGL. So yeah, we just wanted to draw a simple line in the OpenGL, through OpenGL, and as you saw, I just searched for OpenGL, and I didn't search anything about the Java itself or Kotlin, because they have tried in this LWJGL library, they have tried to have the equivalent functions of the OpenGL static methods and functions, with the same name and with the same terminology. So you can use all the stuff out there about the OpenGL. For example, for drawing line, we'll see that we can say GL begin, GL lines, and then it is trying to tell the two points of this line as a vertex, because we are talking directly to the GPU. So vertexes and all these terminologies are the terminologies around the graphical world, the GPU. So let's see if we can run this. Let's copy and paste it here, and I will try to explain all these lines of code here. This is a sample code, but let's first see if we can draw our stuff here. I think we have to add this here, and I'll explain it why later. Let's see. GL begin and GL lines. You see that we are able to import all these functions. They are static functions. So, and I didn't even change the names of the functions, and I didn't have to actually instantiate any objects to access these functions. These are static functions that you can see if I try to navigate. Yeah, you can see these are public static functions, native functions, which just a simple, they just redirect our call to the OpenGL itself, the C library. Okay, let's see, it needs two floating numbers. Let's see, and I think we have to tell the color with GL color, maybe, yes, color 3B. We've had, for example, 20-30 functions for example, for changing the color, and also for you will see actually this is a common pattern here. For example, let's say we want to give it as red, green, and blue, and red is as a double, for example, 1. Let's see, green and blue, and let's see if we will get anything here, and we don't see anything. I think it's because of the decimal system, because you can change the orientation in the OpenGL. You can say that, okay, I want the origin of this origin to be at the bottom or at the top corner, or you can do anything. You can say that I want a a spherical, I think, decimal system, you know, positioning system, or a flat Cartesian system, and you have all those options. Let's see if I'm right. I think by default in the OpenGL they have the Y and X axis at the center, and the center is 0 and 0, and the other sides are 1 and -1. So let's see if we have a line from 0 and 0 to 1 and 1. Let's see what will happen. And yes, and you can see that we have a line here which is white because we gave the color as 1 1 1 for the green, red, and blue, which gives us the, let's see if we, for example, let's say if we give this a 0 and the blue 0, let's see if we can have a green line. And yes, we have a green line. So, and we can get rid of these semicolons because we have copied and pasted from the internet. Okay, you can see we have a canvas now that we can draw basic stuff. For example, we can draw a line, we can draw rectangles, we can draw polygons, we can feel these shapes, we can have different stroke widths, we can draw text, which is a very difficult task in OpenGL. You'll see it's not simple as other frameworks. It's very difficult. And now that we have this canvas, we will try to write our graphical user interface and we'll try to convert the textual main menu, for example, the admin application, to some buttons actually here. And let's see if we will be actually able or successful or not, because we have a hard job ahead of us. And you know, it's not easy, because all those other frameworks that you know and I showed you before, the Flutter, the Android, your React, Angular, JavaFX, all of them, you know, no exception, all of them are talking to OpenGL. And if I want to prove that, for example, let me just search for Flutter, and you can see that they are telling somewhere here. Let me see if I can. Let's go to this Wikipedia page for the Flutter framework, and I want to show this. So the Flutter engine is written in C++, and the low-level rendering is done by the Skia graphics library. So they are not talking to the GPU of your mobile device through the OpenGL, but they are talking through this Skia graphics library. And also the Android itself is talking through this Skia graphic. So what is a Skia graphic library? The Skia graphics engine is an open source graphics which abstracts away the OpenGL. If you go and read that page, you'll see that the Skia itself is a library framework on top of the OpenGL. So basically your Flutter, when you are writing a Flutter application or Android application, or when you are writing an iOS application which is using Metal or the OpenGL, you are asking for, you know, the framework is asking for a canvas, a window, and a canvas inside it to draw its stuff on that. And then those frameworks like Flutter and Android, they have built, you know, a language on top of the OpenGL just to help developers to describe their content without being without, you know, going into details of how these things are working and how these things are being rendered. And we will try to replicate that. We will try to do the same here. So I think it's enough for this session. So in this session, we just we successfully run this OpenGL program, this simple OpenGL app program in the Kotlin. You know, all these lines of codes are written in Kotlin, and we will use just only Kotlin language. And from the next sessions, we will try and we will see if we can draw more complicated stuff and build our own graphical, front end framework on top of this library. Okay, I think it's enough, and that's enough for this session, and thank you, and stay tuned. Bye.